How can we get 100% marks?
Hi Krishna, how are you doing?
I'm doing good. How are you?
Very good, very good. So today, what do you want to do?
I have an exam coming up, so maybe just a whole course review about the grade 12 advanced functions.
Perfect. So this is MHF4U, Advanced Functions, Grade 12 in Toronto, Canada. So Krishna, before we start, can you tell me something about yourself and what kind of marks are you getting?
Okay, so I've been a student of yours for almost 2 years now, and I have almost like a 99 in the
Great,
course.
great. So 99, so close to 100. That's the perfect score for me. And
Yep.
you are definitely one of the best students of mine.
Oh,
I
thank you.
do expect, I do expect some awards and scholarships for you moving forward and admission to the best university in the course which you want.
Okay, thank you.
Perfect. Today, what do you want to do?
So the exam's gonna cover mostly on polynomials, rationals, and trig and log.
Right.
So maybe some of those.
Great. So let's take up some questions. We can review all these concepts. I'll share with you a whiteboard and some questions. Let's go through them, right?
All right.
Perfect. It is the values for x and y are given to us as -3, -24, -20, -118, 030, 136, and 236. So how will you find equation of this polynomial? Can you tell me what kind of polynomial do you expect?
So I would expect maybe a quadratic function. But to check, we could use the differences.
Finite difference.
Yep.
You're right. So it could be a quadratic function, right? But it's good to use finite difference, right? So
Yep.
let's find finite difference from the y values given to us.
Okay.
So 0 minus 24 will be 24. 18 minus 0 is 18. 30 minus 18 is 12.
12.
This gives me 6. That gives me 0. Correct?
Yep. Correct.
So which is not constant. So I'll find the second difference, right?
Yep.
Second difference will be 18 minus 24 is -6. This is also -6, -6, and -6. So second difference is constant. Meaning you have a quadratic function, right?
Correct.
So what type of equation can you use? You have a couple of options for quadratic function. One is you could write y equals to ax squared plus bx plus c, right?
Yeah. Correct.
You could also write factored form like x minus, let's say, p times x minus q. Or you could write the vertex form ax minus h whole square plus q. Which one will you prefer?
We could use the factored form since we already have like an x-intercept.
That's a good idea. So this is the factored form using, because we have an x-intercept, we know at x equals to -2, y equals to 0, correct?
Yep.
So
Correct.
we are using, therefore, the factored form. Now, can you find the value of a from the finite difference?
We could square the second difference and then divided by 2 factorial because it's quadratic.
So here is the relation, right? How do you find the value of a from the finite difference, right? So second finite difference is actually constant for us, and therefore we can write the value of a as constant finite difference. This is the second finite difference, which is -6 in our case, by 2 factorial. Second finite difference is -6. -6 by 2 factorial means 2 times 1, right? And
Yep.
that gives us a value of -3. So the value of a is -3, correct?
Yeah. Correct.
And now we could write a quadratic formula as y equals to -3, x root at -2 will make it +2 here, and the other one we don't know, let it be p, right?
Yeah. Correct.
Now to find the value of p, we have to pick up another point from the data. Which point will you prefer?
We could use 0 and 30.
So 30 for y and 0 for x. So we get 2 and minus p. And dividing 30 by minus 3 times 2, we get the value of minus p, right? Or I could have just made it plus. One and the same thing.
Yeah.
And that gives you what? That gives me a value of 5, right?
5, and then be
So we
minus.
have our formula, right?
Yeah.
Which is minus 3 times x plus 2 and x minus 5, correct?
Yeah, correct.
That means we have roots at x equals to minus 2 and x equals to 5. Perfect?
Yeah, perfect.
So that is your quadratic function. Well, Krishna, you could have now seen here very easily that there are 2 points, x equals to 1 and 2, which give you 36 as the value, right?
Yeah, correct.
So that means the vertex is right there in the middle, right?
Yeah.
Which is we expect at 1.5. From here also you can verify that if I add and do the average, we can get the axis, right?
Yeah.
Minus 2 plus 5 divided by 2, which is 1.5. Do you see that?
Yeah,
We
I
have
see
a
that.
parabola and its equation which relates to this particular data, right?
Yeah, correct.
So that is how we could actually do it. Now let me take some other question on a different topic. Let's talk about rational function and take a question there.
Okay.
So I'm going to clear the screen. So you need to tell me about the asymptotes, right? So we'll talk about horizontal asymptote, vertical asymptote, oblique asymptote, correct?
Yeah, correct.
If the equation is, let's say, 3x minus 5 over, let's say, 2 minus x, 2 minus x. So what kind of asymptotes do you expect here?
It would be the horizontal asymptote would be the ratio of 3 and minus 1, which would be minus 3.
Very good.
And then the vertical asymptote is when you set the bottom equation equal to 0.
Correct. Now, let me give you another example. X cubed over x squared minus 4. What kind of asymptotes do you expect here?
You would have an oblique asymptote.
Yes. And how will you find oblique asymptote? You have to divide it, right?
Yeah, you have to divide.
So you divide minus x cubed. So when you divide, you have to write other terms with 0 coefficient. Do you see that?
Yeah, I see that.
And then you divide with x squared, and then you have here plus 0x minus 4, right? It goes x times. So
Yeah.
x will come here minus x times. So you get
Okay.
minus x cubed plus 0 and minus 4x.
Correct.
Minus and minus becomes plus. So when you take away, you get minus 4x as the denominator, right?
Yeah.
Then you cannot further divide. That means you have an oblique asymptote, which is y equals to minus x, right?
Yeah, correct.
And the other asymptotes are?
It would be plus minus 2.
So x equals to plus minus 2 are your vertical asymptotes.
Vertical asymptotes, correct.
Absolutely clear. The last one which I'm going to test is this 1 minus x squared over x plus 2 whole square. What kind of asymptotes do you expect here?
You would have the horizontal asymptote would just be y equals 0.
Y
And
equals to 0?
because it would be the ratio again.
A ratio.
A ratio, yeah.
Minus 1, right?
Minus 1.
The
Yeah,
coefficient
correct.
here, y goes to minus 1. And vertical asymptote is that?
It would be at negative 2.
Negative 2. So that is how we can actually get it. So we have a horizontal and negative. Now this is a very important function. Now we'll try to see how do we sketch this function. Is it okay?
Okay.
So let me clear the screen here and rational function sketching. So we have this function which is 1 minus x squared over x plus 2 whole square. So when you want to sketch this rational function, what all things should you consider? Tell me.
So first, you should use the asymptotes.
Okay. So we have vertical asymptote, which we just worked out, x equals to -2. Horizontal asymptote, which was at y equals to -1. Right.
Yeah, correct. And
Let me
then,
put this information right there and tell me what is the next thing which you would like to do.
so
Yeah,
we could do the x-intercept.
x-intercept. So what is the x-intercept here?
Would it be
Y equals to 0 will happen only for x equals to plus minus 1, right?
yeah, plus minus 1.
And what is the y-intercept?
The y-intercept would be
Plugging x
1
equals to
over
0,
4.
1 over 4. Perfect, 1 over 4. So y-intercept is 1 over 4, somewhere there, right?
Yeah, correct.
The x-intercept is plus minus 1, so midway, right? Because the vertical asymptote was at -2, right? So
Yeah.
now, how will you sketch the graph? So vertical asymptotes are there. What is the behavior when you're approaching the vertical asymptote?
When you're approaching, it would
As x
so
approaches from, let's say, this side,
this
means
side,
-2, but from negative side.
uh
Denominator is always positive, correct?
yeah, correct.
Numerator will also make it positive. And if I put a value more than 1, it has to be a negative value, correct?
Yeah, correct.
So both sides, it is going to approach down, correct?
Yeah, correct.
So we get this part. We have the horizontal asymptote at x minus 1. So we expect this side should be like this, correct?
Correct.
On the right side, you see there are x-intercepts, y-intercept, all those things. And then as you approach infinity, which is what happens when x approaches positive infinity? Y approaches a value, which is -1. But you have to decide whether it is more than -1 or less than -1.
Would it be more than -1?
It will be more than -1. You can plug, let's say 1,000, right? So plug
Yeah,
1,000, you'll get more than -1. So it is approaching from top, right? So how will you
correct.
connect these points? So it gets connected like this. It actually goes like this, crosses, may not go exactly over it, because see, let me draw it.
Oh,
It has to go. That is how it is going to go. Do you see that part?
yeah, I see that
Because
part.
once it goes, it has to come back. And very important thing, which you have noticed, that in this particular case, your graph has crossed horizontal asymptote, right?
Yeah, correct.
That is possible because horizontal asymptote is only defined at the limit approaching infinity, the other
Yeah,
end. So that
correct.
is how we are going to sketch the particular graph. And we can now label it. This is 1/4 for us. We have labeled all of the things. Labeling is very important, as 0.5 marks can be lost on this, right?
Yeah, correct.
So that's good. So we have done a rational function. Now we could take a trigonometric function.
Okay.
Fine. Let's clear the screen. So identify phase shift and period. These are two difficult things to identify from the given equation. So I'm just giving you an equation, which is
Okay.
y equals to, let us say, 5 cos of, let's say we have 2 over 5x minus 5/8. So in this case, tell me, what is the phase shift and what is the period?
So you would first factor out the 2 over 5.
Excellent, excellent. That is a common mistake done by many students, right? So you have to factor out, then you get the right result, right?
Yeah.
So minus pi by 8 times 5 over 2. You get the idea?
Yeah, I get
So
the idea.
basically, you get 5 cos of 2 over 5 x minus 5 pi by 16. And now we can do time period t, which is 2 pi by k, right?
Yeah.
Which in this case is 2 pi by 2 over 5. 2 and 2 cancel, so we get 5 pi, right?
5 pi. Yeah, correct.
And phase shift is small p, I'm writing 5 pi by 16 to the right, correct?
Yeah, right.
Perfect. So question done. Now, let me ask you another question on this. So, let us see how do we find equation from a graph, okay?
Okay.
So, let me just sketch a part of the graph here.
All right.
All right. Now, here I'm giving you 2 points. One maximum point I'm giving you as, let us say, this is somewhere around, I'll give you these 2 points, maximum minimum points, right?
Yeah, okay.
So let's say the y value is 2 and the x value I'm still thinking about is, let's say, pi. So at
Okay.
pi we have this value, and here we have, let us say, this value is, let's say, 2 pi by 3, and the y value is minus 3. Tell me, what could be the equation of this graph?
So first you get the A and C values.
Okay, so what is it?
You would add or subtract the max minus the minimum, so and then divide it by 2.
Correct. And
And
then you get x's, right?
yeah. And then it would be the max plus the min, so 2 plus minus 3. And then divided by 2.
Correct. So which is minus 1 over 2, right? 0.5.
Yep, correct.
This is your answer. Correct. Time period.
The time period would be 2 pi.
So difference times 2, right? Double.
Yeah, yeah,
So
double.
you do this, right? So you get I should have written 5 pi
Oh, 5.
here. Because that is smaller value. Okay. So 5 pi by 3 minus this. So multiply this by 3. So you get 2 pi by 3. Is that okay?
Yeah, that's okay.
Times 2, which is 4 pi by 2. So that is what you get. And if you are writing it as a cosine function, what could be now the function? Tell me.
So it would be
Ab-
minus 0.5.
Cos is here, right?
Yeah,
So amplitude is, we are writing in the form a cos k x minus p plus q, right?
yeah, correct.
So amplitude is 2.5. Cos of k value. K is how much? K is
K's
like this, right?
yeah, 4 pi by 3.
So k equals to 2 pi divided
Oh,
by 4 pi by 3, right?
oh yeah.
So which will give me pi and pi cancel, 3 by 2. So we get 3 by 2 x minus. You move 2 units to the right, right?
Yeah.
And you move down by 0.5. So
Correct.
This will be minus 0.5 or half, correct? So that is how you could actually get the equation from this particular graph. Clear?
Yep, that's clear.
Perfect. So that's how you'll do it. Now, let's take another question, which is, so from my set of questions, I'm just taking out few for us to try. Okay, so we'll solve an equation, and I'd like you to tell me the values. So here is an equation. This equation actually gives you hours of daylight in Vancouver.
Okay.
So sine of 2 pi over 365 makes sense, right? 365 days.
Yep, makes
and
sense.
80 plus 12.76, correct. So the time number n is number of days since 1st of January, right? So 1st January will be the first day, right?
Yeah, correct.
Days from 1st January. Correct. So on which day will the temperature be? Let's say 14. It's not the temperature, number of hours there will be a sunshine, right?
Okay.
So can you calculate when will H be equal to 14? How will you do it?
So you could substitute H for 14 and then solve for N.
Yeah. So 14 minus 12.76, correct?
Yep,
You
correct.
divide by 4.2, correct? To
Yeah.
get the sine value of 2 pi by 365 times n minus 80. So let this be theta. So what could be the value? So what could 2 pi over 365 times n minus 80 be equal to? You do inverse of this, right?
Yeah, you inverse sine.
So what do you get? Can you just do it and tell me?
Oh yeah, so it'd be
It's a positive value. We are expecting two answers. You'll give me one, which is the related acute angle. And the other one, we are going to find using pi minus the angle. So put it in radians. Everything
Yeah.
is radians. Yeah.
Okay, so I got a decimal 0.2997.
Correct. So this is one value, which is the related acute angle. Sine is positive. Apply the cos rule, correct?
Yeah, correct.
So we are looking for two solutions. Second will be
Pi minus
0.299, right? How
yeah.
much is that?
It is 2.84188.
Perfect. So once you have these two values, you can calculate n. So from the first one, n will be equal to 0.2996 times 365, correct?
Correct.
Divided by 2 pi and then add 80 to it, correct?
Correct.
You can calculate this for the second one. N will be equals to, you can have this value 2.84188 times 365 divided by 2 pi. And once you do that, plus 80. You get the idea.
Yeah, I get the idea.
So that is how you can actually answer this particular question. Clear?
Okay.
Let's take a simple question. Let us say that cos theta is equals to 3 by 5. In that case, can you tell me what will be the value of cosecant theta? Possible values of cosecant theta.
Okay.
How will you do this?
Cosecant is the inverse of sine, right?
Yes, it is inverse of sine.
So you could get the y value from the 3/5.
Got it. So let's get. So we have cos theta as, let's write down theta 3/5. Correct. So
Yeah,
this
correct.
will be 4, 5 square
4.
minus 3 square square root.
Yeah, that's
And
4.
therefore we get this value. But remember one thing, that you are working in cos theta as positive in 2 quadrants, correct?
Yeah,
So
correct.
you have to provide 2 answers, one for quadrant 1, the other one for quadrant 2. Right? I mean
Okay.
quadrant 4. So don't forget that, right?
Yeah.
So here cosecant theta will be how much?
It would be r over y, which would be 5/4.
And in this case, cosecant theta will be minus 5/4.
Yeah.
So do not forget the other part, which is minus 5/4. Is that clear to you?
Yeah, that's clear.
Let me take examples from logarithms from my videos.
Okay.
So here is a question on logarithms. You need to solve this logarithmic equation, which is 3 minus log to the base 3 of x plus 2 equals to 4. How will you solve this?
Okay. So you could subtract 3.
Right. So it can take log on the other side. So log to the base 3
Mm,
of x plus 2 will be equal to 3
1.
minus 4, which is minus 1, correct?
Yeah.
Then
Uh uh
exponential form, right? 3 to the power of minus 1, correct?
yeah,
And x
correct.
is equals to 3 to the power of minus 1 is 1 over 3.
And then
1
minus
over
2.
3 minus 2 gives you the value of x, correct?
Yeah,
But
correct.
remember one thing, in this particular case, this log is only valid for x values which should be greater than minus 2, right?
Yeah,
So
correct.
when you calculate this value, what do you get? Now let's take a graphing question, let's say. So here's a trig identity for you. We have sine 4x over 1 minus cos 4x times 1 minus cos 2x over cos 2x equals to tan x. How will you do this?
Okay. We could start by maybe expanding the cos 2x with the like the double angle.
Formula? Yeah.
Yeah.
Okay. So which double angle formula will you use? Cos 2x has 3 double angle formula, right?
Yeah, that's correct.
Tan x, we have to ultimately get 4x into x form and 2x also into the x form, right?
Yeah.
So on sine 4x, we have 2 sine x cos x, 2 sine 2x, right? Cos 2x, correct?
Yeah, correct.
There are no options here. It is this formula. Now,
Okay.
1
Yeah.
minus cos 4x, let's convert this side to sine itself. Is it okay?
Okay.
So cos double angle formula, let me write down here. Cos 2x is basically equals to 2 sine square, 2 cos square x minus 1, or it could be written as 1 minus 2 sine square x, correct?
Yeah, correct.
So if you rearrange, then 2 sine square x can be written as 1 minus cos 2x, correct? Now
Correct.
here it is 1 minus cos 4x. You see that part?
Yes, I see. Yeah.
So 1 minus cos 4x can be written as 2 sine square 2x.
Okay.
So this is a better approach. You see how we have rearranged the formula and simplified that, correct?
Yeah, I see that.
Similarly, 1 minus cos 2x 1 minus cos 2x can be written as 2 sine square x, right?
2 sine squared. Correct.
And now we have cos 2x. Cos 2x can be written as either one of them, right? So, or we'll just keep cos 2x for now because we can cancel cos 2x. Do you see that cos 2x?
But yeah, I see that.
So, cancel away this cos 2x with this cos 2x. And since we have sine square 2x here, one of them also gets cancelled.
Correct.
2 and 2 also gets cancelled, right?
Yeah.
So let me rewrite the left-hand side. So left-hand side basically is now what? 1 over sine 2x
Correct.
times 2 sine square x, correct?
Yep.
And clearly, 1 over sine 2x means we have to write 2 sine x cos x, correct? And the numerator, we have 2 sine square x. Perfect?
Yep. Perfect.
So one of these sine square x cancel, 2 cancel, and we are left with sine x over cos x, which is 10.
Correct.
So actually speaking, this is the most efficient way of answering this question.
Okay.
How beautifully we have utilized this double angle formula and simplified our terms without doing much of effort. Okay, so make a note of all this.
Yep.
So I think that's a good one. And now let me take up some other question. Now here is a very difficult question, which is simple to see. You have to find the solution of sine theta equals to cos 3 theta, where theta is from 0 to 2 pi. How will you solve this?
So first we could maybe start on the right side,
Okay.
the cos 3 theta.
Yeah. So you can write down what is the expansion of cos 3 theta, right?
Yeah.
So do you know cos 3 theta formula or we'll derive it?
No, I don't know it. Yeah.
So first thing is we may have to derive the cos 3 theta formula, right?
Okay.
So cos 3 theta can be written as cos of 2 theta plus theta, right?
Yeah. Correct.
Which is cos 2 theta cos theta minus
Sine 2 theta.
sine 2 theta sine theta, right? Now, again, cos 2 theta can be written as 2 cos square theta minus 1, or you like 2 cos square theta minus 1. We can write 2 cos square theta minus 1 times cos theta
Correct.
minus, this is 2 sine theta cos theta.
Yep.
Let's open this bracket. We get 2 cos cube theta minus cos theta
Correct.
minus sine square theta. We get 2 cos theta here.
Yeah.
And we have times 2 sine square theta.
Sine square theta. Yep.
So sine square theta can be written as 1 minus cos, then we get the similar terms, right?
Yeah. Correct.
Open the bracket,
Mm.
2 cos theta plus 2 cos cube theta. And that gives you 2 cos cube theta, and 2 cos cube theta is 4 cos cube theta,
Yep.
and minus 3 cos theta.
Correct.
So we got this formula in terms of cosine, right? 4 cos cube theta minus 3 cos theta, correct?
Yep. Correct.
So you can rewrite your equation, which is basically sine theta equals to this. Now, how do you solve this further?
Um.
You're using sine. because we used 2 theta, right? We converted sine square theta into cos square theta, correct?
Yeah,
In this
correct.
particular question. And that's why we landed up in an equation which was sine theta equals to 4 cos cube theta minus 3 cos theta. And it really doesn't help us much. You get the idea,
Yeah, I get the idea.
right? So we'll have to have an alternate approach. So that's what happens. So let's have an alternate approach, and I'll give you the approach. You work on that, correct?
Okay.
So basically, the equation was sine theta. I'll also provide you reference of my video for this particular solution. Okay.
Yep. Okay.
So it is equals to cos 3 theta. So what I prefer to do is to write sine of theta as sine of 2 theta minus theta, right? And here
Okay.
I write this as cos of 2 theta plus theta, correct? So
Okay.
I'm trying to convert this into 2 theta rather than theta.
Okay.
That's the idea. And
Yeah.
once we do that, then we will be in a position to solve this equation. So I like you to continue with this solution and refer to my videos.
All right.
Correct? So we'll end our class here. I hope you find these questions interesting and useful.
Yeah, I did.
Okay, Krishna. So how did you find this particular exercise?
I found it like I learned something like a new formulas this class.
Perfect. So I'll share the link for the solution of the last question. That is going to help you, provide you with another new approach.
Okay.
And in the first video, which was very simple, finding equation, quadratic equation, we did learn a new formula. How do you find the value of leading coefficient A? Leading
Yeah,
coefficient
correct.
A is basically finite difference divided by n factorial, where nth difference is finite. Perfect.
Yep, correct.
And in trigonometric equations, you have to provide all the solutions.
Mhm.
So not just in quadrant 1 or one quadrant, you have to see which are all the possible values to work with.
Yeah, correct.
And in another trigonometric equation, we did figure out that if we use judicially the cos 2 theta formula, we can cancel out many values. And that product thing which we did, we
Mhm.
could do it much faster than otherwise. So
Yep.
I hope all these things help you a lot. All the best for your exam, and we expect another 100% from you.
All right. Thank you very much.
Thank you. All the best.
Thank you.